You all slept well? I didn't sleep that well either. Hope you did. So next week is our last week. Well, I'll do announcements later. Okay. So we'll start in about 10 seconds. So get this ready so we can start. Okay. Ooh. All right, shall we start? You guys ready? All right, here we go. So today we're going to continue to talk about surface area, and but we're going to talk about pyramids and cones today. Today is the 28th. Okay. And then we are going to calculate of pyramids and cones. All right. Okay. So surface area, right? Surface area is still talking about area of a surface. So we need to examine the surface of a pyramid. If you look at this, you realize that the pyramid is a little different from prism, right? Prism has two bases, pyramid only has one base, so you just do one base plus the lateral area, right? The lateral area are these on the side. And once again, we don't look at non-regular pyramids or not right pyramids. In this case, we're only looking at right pyramids, okay? So when you expand any right pyramids or regular pyramids, you would get something like this, okay? Notice that all of these are isosceles triangles, okay? You will expand into however many sides, right? So in this case, you have 4 sides on a square pyramid. So to find the surface area, obviously you have to do every triangle, right? So it's the same thing as doing every triangle. So half base is the side length times height. This height is the height of the triangle, which in the pyramid, it's not the height of the pyramid, but it's slant height, right? Because when we do surface area, we want to use all the dimensions on the surface. On the surface for the triangle, the height is slanted relative to the pyramid, but that's what we're going to use when we calculate surface area, because that's the area that I'm looking at, right? The area and the height is for that area, okay? So find the height, and then in this case you have 4 of them, so you times 4, right? Notice that the lateral area is 4 times the triangle, right? Four triangles. If you notice right here, this part right here, 4 and S, okay? 4S is the perimeter of the base, right? So, because multiplication is commutative, we can then combine them. So 4S will be P, so 1/2 P L, P, because 4S is the perimeter, okay? Alternative way to look at it is if you line them up like this will, and then you draw a rectangle around it, you realize that the area is exactly half the whole rectangle, which is half PL, okay? So if you go down here, you can see that lateral height is half PL, P is perimeter, length is slant height, L is slant height, and surface area is 1 lateral area plus 1 base only. Okay? Let's go back down here and let's try a problem. Okay? So lateral area, lateral area is going to be 1/2 perimeter times slant height. 1/2 perimeter for this is what? This is a regular hexagon, and side length is 10, so the perimeter is going to be 10 plus 10 plus 10, 60, right? 6 sides. Slant height, they already tell you 16. So lateral area would be 480 inches square. Is that right? That's lateral, right? But we also need, so lateral means that the triangle's around it. And now we're going to look at the base. What shape is this base? Well, we have been doing this for a long time already. Hexagon. Side length 10. Alright, since we've done this for so many times, I want to give you 2 minutes to do this part. And afterwards, you can add them up to find the actual surface area, right? Because the base area plus the lateral area will be a surface area. I want you to spend 2 minutes to find the area of this hexagon, okay? Go. I think you are close, Keon, but I don't think it's 300 exactly. The reason it's not is because the height is not 10. You got to find this approximate height first, okay? If you remember and recall how we did this was 5 and this was 30 degrees because the whole thing is 60 degrees, and then you cut in half. Okay, 30. Okay, this is 5. So you remember we use tangent 30 equals 5 over 8. I'm pretty sure, Matt, you didn't divide by 2 or something like that. The answer should be 256.81, I think, around that range. Okay. If you forget, you have to find an area of a triangle first, and then times by 6. Okay. And to do that, you have to first find the bottom, and we've done that many times, right? Okay, so once you find the base, you just add them up. So the surface area will be these two added together, which is 739.81 inches square. Okay. All right. So you try one. Okay. While you try one, once you're done, you can type the answer down. But let's take attendance while we're doing it. So if you're here, let me know you're here, and we'll go from there. All right. We got good answers. Darren, I like your answer. $800 looks good. So lateral area is 1/2 perimeter times slant height. 1/2 perimeter is 16 times 4, so 64. Times slant height is 17, right? That will give you 544. Okay. And then the base area is a square, so it's 16 times 16. So that's going to be 256. And add them up. Surface area is 800. Okay. Comfort level 1 to 10. Give me a number for this part. Okay, not bad. Let's continue then. So next part is then the cone. Now, I mentioned before with you guys that cone and pyramids are basically the same thing, but cone is circular, right? So all the formula that applied for pyramids will apply to cone. So for example, your pyramid area was 1/2 PL plus base area, right? That's what you have. Now, if you look at it, perimeter for a circle is pi r, 2 pi r, right? 2 pi r. That's the circumference of a circle. Slant height is still slant height. What's the base? Isn't the base a circle? So it's pi r squared. Now look at it. You see how 1/2 and 2 can cancel? Like that. 1/2 and 2 can cancel. So because of that, you can then have this formula. Pi RL plus pi r squared. That would be your surface area. Good, bad, okay? Makes sense? I'm going to use it now, okay? So we use the same exact formula, but now they're all circles. So circle has circle perimeter, which is circumference, and base area is pi r squared. Okay? Let's look at this. They want you to find the lateral area and surface area of a cone. So lateral area is pi RL. Pi RL. And then, so pi 8. Hey, I don't have L. What is L? I got you, Kina. I got you. How can I find this lateral height or slant height? What property or theorem can I use to find that? Pythagorean theorem? Right triangle here, right? Square root is 161. Yeah, 161. 15 squared is 225 already. Oh, you're subtracting? But this is a slant, this is a hypotenuse. Right? So you add them up, this is 289, square root is 17. Okay? Because the slant height is the hypotenuse, right? A squared plus B squared equals C squared. Okay, use this for this one. So you get 17. Also, you should kind of memorize this combination. It's one of the Pythagorean triples that we use a lot. So there's 3, 4, 5, 6, 8, 10, 5, 12, 13. Right, let me write some down. So 3, 4, 5, and obviously all the ratios. So 6, 8, 10 is the same thing as 3, 4, 5. We also have like 5, 12, 13. And then the other one's this one, which is 8, 15, 17. These are the basic 3 that we use a lot, okay? Obviously, these 2 more than this one, but this one is the most. Then this, okay? These are the Pythagorean triples that works for Pythagorean theorem, okay? Full number solutions. And the ratio of them. So if they're all multiplied by 2 or divided by 2, same thing. All right, so 17 here. Multiply out. Should get 136 pi. Okay. And the base area would be pi r squared, right? So pi r squared, pi 8 squared, which is 64 pi. Right? Add them up. Surface area is, add these up, I think it's 200 pi. And units is in square inches because we're doing surface area, right? It's 2-dimensional. Make sure you have this square here, okay? You try one. You try one. Give you 2 minutes. Yeah, when you're done, give an answer. See a bunch of 144 pi. Alright. I think you're right. Pi r squared, right? R is 8. Center high is 10, right? 6, 8, 10. Just talk about this. So, pi r l, right? So 80 pi for lateral. And then your base area is pi r squared, which is 64 pi. Right? And then you add them up. 144 pi centimeters square. Okay. All right. So last concept we're going to talk about today is they will tell you if you need to keep it in pi or you need to do decimals, okay? So you don't need to worry about this kind of details. But leaving it in pi usually is fine. Unless they want you to change the decimals, in that case, then you would multiply it out. Okay? But in most cases, leaving it in pi is better. Most cases. Alright. Unless there's a combination between the two and they want like an approximation, then you can put in pi. Okay? Sorry, you can put in decimals. Alright, so today we're going to talk a little bit about shrinking and expanding the whole solid and what that has to affect the surface area. Okay, so they say, what if so this is a regular hexagonal pyramid. What if I divide both the edge length, which is 10, is now divided by 5, and also slant height divided by 5, then obviously dimension will change. This will be 2, this will be 3. What kind of effect does that have on my surface area? Meaning, by how much, obviously it's going to be smaller, by how much does the area shrink? Okay. So the problem is this. Originally, let's just look at a triangle, okay? Because the base area obviously will change accordingly. But the triangle was 10, 15, right? That was the triangle. And then now the triangle is, what? 2 and 3, right? That's what it looks like right now. What's the area? First of all, what is the ratio between them? This is 5 to 1, right? You agree? 5 to 1. So, if you calculate the area, what's the area of this? Half base times height, so that's 75. So this is length ratio. What about area? Area is half base times height, so 75. Half base times height, so 3. What is the ratio here? 75 to 3. You can take out 3. That's the same thing as 25 to 1. How are these related? 5 to 1 versus the area is 25 to 1. How are they related? Isn't 25 5 square? Why is that? I think we mentioned this when we were doing similar triangles, is that if you change the scale factor of the length, right? Since area is two-dimensional, your area would be your scale factor square. If it's volume, then it will be scale factor cube. Okay? So that's why it's 25 to 1. Okay, so you can say surface area will be 1 over 25 of original. Okay, this will be smaller, right? You try. What do you think will happen to this one? So, just like how you square the ratio, now you multiply everything by 2/3, the effect will be squared, right? Because it's the area, two-dimensional, right? Two-dimensional is squared, because you have length times length, and length is 2/3, height is 2/3, so together it's 2/3 square. So So that's 4/9 of original surface area. Okay. If they ask you volume, then it'll be cubed. 8/27. Okay. Last one. Oh wait, hold on. Give me 1 to 10 on this concept. This particular concept. Just this part. So let me see if I need to explain it more. Seven to all right, that's good enough. All right, find surface area. This surface area, another composite figure. Let me remind you that this part is covered, so obviously this doesn't count, okay? Because we're talking about surface area, so it's not on the surface, we don't count it. So the area becomes simple, right? You just do two laterals, this part and this part. What's the lateral area? Well, we need two lateral area, right? So lateral area is cone is pi RL, right? So 2 times pi r is 2, L is 6. So we got 24 pi feet squared. Okay? Make sense? Because the middle part is covered, you don't look at that. Okay? Alright. So, let's talk about a few things that's coming. So first of all, homework for this week is already on Big Ideas. It's called 11.7. Okay? And it's due Sunday, the 31st of May. So next week is our last, so this is the first announcement. Number 2 announcement. Next week is next week. Originally I was going to give you a final, but I feel like, you know, we don't even have finals this week, but I give a final. So 11.8 spheres. This is going to be the last class of the year. Possibly your last class with me ever. Isn't that exciting? You can get rid of me forever. So we're going to do a lesson. 11.8 is relatively short, I would say. Well, but we have to cover both surface area and volume. So we'll see. But yeah, that's pretty much it. We should have a Zoom meeting for the last class. Maybe. If that's the case, then I might send the Zoom link out. Okay. I don't know. Some people don't like to show their face. Kahoot. Interesting. Maybe this is what I would do. I would first start with this, because we still need to do notes. After we do the notes, then we can do Zoom, and then I'll put the Kahoot onto the Zoom. Does that make sense? I think that makes perfect sense. I'll share the screen and we'll do a Kahoot for review. How about that? So we'll do notes first, and then we'll do the Zoom meeting for Kahoot for review. Okay? Does that make sense? Parrot, I think you're worrying too much about 11.8 right now, where you didn't even do like 11.6, 5, 4, 3, 2, 1, those homework. I'm still deciding if I want to give a homework for 11.8. Most likely not, though. Most likely not, because I don't want to look at them. But it's next week is last week, right? He's been exposed. This guy act like he's a good student, but he doesn't even do homework. You have everything done except for 11.4. Where are the pictures? Where are the pictures? I don't see nothing. Anyhow, all right. Anything else? So next week we meet at the same place first, okay? And then during class I'll redirect you somewhere else. If we're doing the Kahoot and Zoom and stuff, okay? You did them on big ideas because they were on time. Let me check. You have like some sort of imagination or something. The only thing you have done is pretty much like chapter 10 test. Let me see. Yeah, that's my email. Like, yeah, you didn't even start 11.5 yet. Have you not been keeping track of school loop grades? Like I put all your missing assignments there. I don't see you doing any homework. Am I just imagining things, or what? Or are you in some random class that I'm not aware of? You're in period 6, it says period, and you haven't done any homework. It doesn't. No, he didn't even start the assignment. It's not about submitting. He hasn't started them. Like they're all blank. Like if you didn't submit, then it'll say in progress, and it'll tell me which problem you didn't do. This guy. Alright, you did 11.4. I see that one. I think I give you grades for that one, right? Uh, 11.4 you did. Oh, never mind. I think they look good. I'm just playing with 11.5 you haven't done. Okay, 11.5 you haven't done. I don't know why I think that. Did you do something? Oh, I remember. You didn't do 10.7 before, and you didn't do 11.3 before, right? And then you made that up, right? Oh, I remember why I feel like you haven't done so many, because you haven't, and then you made it up, and then I forgot that you made it up, and I give you grades for it, I forgot. So anyway, 11.5 hasn't been done. Anyway. Alright, goodbye, guys. Thanks, period. Bye. Goodbye. Bye, guys. Bye.